जी, तो हमारा नेक्स्ट टॉपिक जो है वो एल्केन्स था और हम एल्केन से स्टार्ट करते हैं। एक सेकंड दें बस हमें। जी, तो आपको पता है कि एल्केन्स का जनरल फार्मूला CnH2n+2 है एंड द नंबर ऑफ n इज ग्रेटर देन इक्वल्स टू 1। नेम एंडिंग उनकी एन है। फर्स्ट 4 मेंबर्स are gases, the next 12 are liquids, others are solids. And they are hydrocarbons, which means that they only contain the elements carbon and hydrogen, and they are saturated compounds, meaning they contain carbon to carbon single bond. Okay, you already know these things. Okay, moving on, talking about the reactions which alkanes carry out. Alkanes carry out combustion reaction, free radical substitution, and cracking. In O levels, you studied substitution, but now you will study free radical substitution. Okay. 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 Free radical substitution is a 3-stage process, and just please don't write anything. Listen to this. First stage is the initiation. You take Cl2, Br2, or I2, anything, and in the presence of sunlight or UV rays, and free radicals are formed like this. Okay. Second stage is propagation. A normal molecule is converted into a free radical, and a free radical molecule is converted into a normal molecule like this. This is the thing that you did in O levels, this one. And you can see this is a very pretty basic thing. You don't have to tell which is a free radical, which is a normal molecule, and what is formed. And so hence forget this for right now. Normal molecule, as I said, normal molecule is converted to a free radical, and a free radical is converted into a normal molecule. Then what happens? Okay. Then there's a termination stage in which free radicals combine to form molecules. That's it. So there are 3 stages. Okay. More. Okay. Now talking about the basic mechanism of this reaction. Okay, you can see over here, sorry, that there is a free radical substitution between CH4 and Cl2. You've got A, B, C, D, E, 5 options. And over here you can see that the third stage is termination. E plus E is Cl, Cl, A plus A when combined form this, A plus D, D plus B form this. Okay. Okay. So basically this thing. Moving on, we talk about the compound C3H7. There's this option and this option. When you combine A and A, you get this. When you combine B and B, you get this. When you combine A plus B, you get this molecule. Over here, you can see that it's written that at the start of the reaction, the mixture contains lots of methane molecules, lots of chlorine molecules, and only a few will have been fractured by the a few chlorine radicals. The breaking of Cl-Cl bond in the chlorine molecule begins the reaction because it is the weakest of the bonds of any of the reactant molecules. Bond enthalpies Cl-Cl is 242, Cc 3.4. Okay. Okay, moving on. Over here you can see that fluorine is the most reactive if number of precautions are taken. A mixture of fluorine and methane explodes. The reaction between methane and chlorine is easily controllable, but bromine is even less reactive than chloride. Chlorine. Iodine, on the other hand, does not react with methane. Hence, we always react chlorine. Okay, now talking about the basic free radical substitution reaction, the basic, you can say, the mechanism. So let me come on to the whiteboard now. Okay, you write over here free radical substitution. Okay. First of all, you talk about the reagent used. You say it is a halogen plus alkane, and the halogen which is used is either Cl2 plus CH4, Br2 plus C2H6. Okay, then talking about the reaction conditions. That is sunlight or UV rays. Now moving on and talking about the mechanism of reaction. ये बात याद रखें कि ये चीज़ें जो मैं मैकेनिज्म तो हमेशा आता ही आता है, और जो मैकेनिज्म का दूसरा स्टेप है प्रोपगेशन, वो तो लाजमी आता है, तो प्लीज़ उसको आपने अच्छी तरीके से याद करना है. First step is initiation, and you say in the presence sunlight or UV rays, Cl2 bond breaks homolytically. Free radicals are formed. Radicals are formed, meaning Cl gives us 2Cl free radical. This gives it to this, and this gives to this. Okay. And the second step is propagation. And in propagation, in each step, one free radical is consumed, while one another free radical is formed. ठीक हो गया. अब इसकी कुछ इक्वेशन है, वो क्या है इक्वेशन, वो देखते हैं. फ्री रेडिकल है, पढ़ा था कि फ्री रेडिकल प्लस नॉर्मल मॉलिक्यूल जब कंबाइन होते हैं तो फ्री रेडिकल नॉर्मल मॉलिक्यूल बन जाता है और नॉर्मल मॉलिक्यूल एक फ्री रेडिकल बन जाता है. ऐसा ही था ना, तो अब इधर भी यही होगा. आप कहते हो H C H H फ्री रेडिकल प्लस HCl. ठीक हो गया. अब आप इसको एक सेकेंड, अब आप इसको इधर ले आओ और आप क्या लिखोगे, HCH फ्री रेडिकल ना प्लस Cl2. अब इसको आप नॉर्मल मॉलिक्यूल में करें, CH Cl प्लस Cl रेडिकल. उसी तरह आप इसको इधर ले आओ तो HCH Cl प्लस Cl फ्री रेडिकल, HCl plus HCl. So HCl plus Cl2. Sorry. HC free radical. H plus Cl2 HCCl HCl plus Cl free radicals formed. Okay, now moving on. Now we say that आपके पास H है, C है, Cl है, Cl है, H है प्लस Cl ऐसे फ्री रेडिकल है और ये Cl 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 प्लस HCl बना रहा है। उसके बाद आप कहते हो फाइनल स्टेप जो है फाइनल स्टेप में इधर लिख रहा हूँ साथ ही वो है Cl plus Cl2 which gives us Cl plus Cl free radical। तो आपके पास CCl4 बन गया ना। बस यही एम था और हमारा क्या एम था, 4 बन गया आपके पास। ओके, द थर्ड step is termination stage। और इसमें क्या होता है, इसमें free radicals combine to form molecules। Okay, this is it for free radical substitution। Let me just wait for 1 minute, please। अच्छा जी, तो हमने इधर फ्री रेडिकल सब्स्टिट्यूशन भी होगी और अब हम आते हैं अगले रिएक्शन की तरफ। अगला रिएक्शन कौन सा है, आप एक सेकेंड। The next reaction is cracking। What is cracking? You've already done this in O levels। It is a breakdown of long chain hydrocarbons into smaller chain hydrocarbons, and two conditions हैं। Conditions for option number 1 is that condition for option number 1 is use Al2 as catalyst at high temperatures। Okay, and another definition for cracking is that it is a process in which vaporized heavy fractions of crude oil at 500 are passed over catalyst Al2, so the smaller alkanes, alkenes, and hydrogen gas are produced। Conditions option 2 is high temperatures and pressure। Okay, cracking is important for the following reasons: fractions that are less needed or exceed demand are converted into more needed fraction. It produces unsaturated hydrocarbons like ethene. Ethene is used in the manufacture of many polymers and plastic. And cracking also means of producing hydrogen gas। Okay, let's take some examples of cracking। We say that you got In cracking, what happens that you've got a long chain hydrocarbon alkane. You can convert into a smaller alkane and an alkene. Like you take C20H42. Please crack this. You've got 1 minute to do this, so I'll be waiting. Okay, so what you've got? Should have gotten. There are 3 possibilities. First of all, you must get C18H38 and C2H4. The other possibility is you got CH4 plus C19H38. The other possibility is C6H14 plus C14H28. I'm sure this is clear. You've already done this in O levels. This should be clear. Another possibility. Okay, another possibility. You got C4H8 plus C6H12 plus C10H22. Okay, I'll give you another example. And that example is C30H62. Crack this, please. What C20H40 plus C5H12 plus C3H6 plus C2H4. ठीक हो गया ना? आपके पास आ गई. इसी तरह आपके पास C30H60 एंड हाइड्रोजन गैस भी बन सकती है और C30H58 प्लस 2H बन सकता है. हो गया ना? समझ आ गई? चलिए, एल्केन्स इधर ख़त्म होता है और हमारा नेक्स्ट टॉपिक जो होगा वो होगा एल्कीन्स.